So we've got Flash and we've got Box2D, and they both use units in different ways. In Flash, everything's in pixels. It's all about displaying objects on screen, and so obviously pixels makes the most sense for your units. You've got a sprite, the X is set at 200, the Y value is set at 400, that sprite's going to be at 200, 400 on screen. Makes sense. So Box2D is all about simulating things as they behave in the real world. And in the real world, nothing's in pixels, things are in real world units. And Box2D uses the metric system. Everything's in meters. So instead you'll say some body, its X coordinate is at 5 and its Y coordinate could be at 8. And so as far as where that maps to on screen, well, actually that brings up a very good question. What does 1 meter equal in pixels? And obviously this is a tricky question because it can vary from game to game. In a game like Civilization, 1 meter is probably 1 pixel or maybe half a pixel. If you're looking at the cellular stage of Spore, 1 pixel is going to be many thousands, or sorry, 1 meter is going to be many thousands of pixels. And if you're looking at weird abstract physicsy games like Crayon Physics or Filler, we have no idea what 1 meter actually is in these game worlds. So your first inclination might be to say, well, if we're dealing with abstract physicsy worlds, why don't we just say 1 pixel equals 1 meter? That way I don't have to do any conversion from one coordinate system to the next. Makes sense, seems like a good idea. There's a problem with it though. It doesn't work very well. And the reason why is Box2D is designed to work best with objects that fit within a particular range. Specifically, on the small end of things, it wants objects that are 0.1 meters or larger. 0.1 meters, it's about, say, the height of a BlackBerry, roughly 4 inches. And on the large end, it likes things to be 10 meters or smaller. 10 meters, roughly the length of a school bus. Drawings are not to scale, duh. So if we were to take a game like Filler and try and make 1 pixel equal 1 meter, instead of these things being maybe large beach balls or something that we're bouncing around, suddenly we're moving around that giant spaceship Earth thing from Epcot Center. Holy crap, that's really big, and because Box2D isn't made to deal with objects this large, it will probably act funny. It won't crash, your game will still run, but it will probably do things that you don't expect if you use objects that are this large. So there's a de facto standard out there that is 30 pixels equals 1 meter. And this generally works pretty well because on the small end of things you've got 3 by 3 boxes, and on the large end of things you've got 300 by 300 boxes. And almost anything you're going to make in a game is probably going to be somewhere larger than 3 by 3 and somewhere smaller than 300 by 300. So this actually covers most of the cases. You'll see this value used a lot. There's nothing magic about it. You could certainly go with 40 pixels, you could go with 20 pixels, you could go with 70 pixels. As long as most of your objects still fall within this 0.1 to 10 meter range, you'll be okay. It just so happens most people go with 30, and so I guess we will too. So let's go back to here. Now, I actually could just leave this. Like I said, there's no problem going too large when defining the size of your universe. However, I think it's a good idea to get in the habit of thinking in 1 unit all the time, because if you're mentally switching back and forth between Flash pixel units and Box2D meter units, you're going to get confused. And because we went into this thinking of it as pixels, let's keep it this way. So what I'm going to do is I'm going to go up here and let's create a public static constant. We'll call it ratio for the ratio of meters to pixels, or I guess pixels to meters. We'll make it a number because we're using it in division. I think numbers work better. And let's call it 30. Actually, you know what? Because I am that kind of rebellious guy, let's make it 40. Just to show you that there's nothing magic about this 30 number everybody uses. So, ratio of pixels to meters. And then we're going to go back down to this universe size, and we're just going to divide everything by this ratio constant that we have just created. So now basically we're telling Box2D to create a universe of the right size in meters that will equal this 6,000 by 6,000 universe that we are expecting to see in pixels. Okay, we are almost done, I swear. We just have a couple more steps, and then we'll actually have a world working. So stay tuned.